All right, remember this is section 3.7. This is video number 2. And we are talking about inverse functions. So take a moment and I want you to fill in the blank. Ugh, I can't even talk. Because I want you to fill in the blank at the end of these sentences in your notes. Right now, pause the video and fill in the blank. All right, hopefully you got those filled in. Given g of x is a one-to-one function and it has an inverse, g inverse of x, the inputs of g of x become the outputs of g inverse of x. And the outputs of g of x become the inputs of g input of x. Remember, x and y just swap. So x becomes y becomes x. So the domain of g inverse of x, so the inputs for g inverse of x come from the range of g of x. And the range of g inverse of x comes from the domain of g of x. So let's say we have a one-to-one function with a domain of x greater than 2 and a range of y less than 1. Find the domain and range of f inverse of x. Well, first, let's write this domain for f of x. That's x greater than 2. Let's write that in interval notation, 2 to infinity. And the range for the original function is y is less than 1. So that's minus infinity up to not including 1. So for f inverse of x, so these guys are for f inverse of x. The domain of f inverse of x comes from the range of f of x. So it would be minus infinity to 1. And the range of f inverse comes from the domain of f. So that would be 2 to infinity. All right, let's talk about graphing inverse functions. Well, let's just make a nice table of values and see if we can't graph it. First, I'm going to pick off some values on my function f of x and y. And then I'm going to swap them and put them on for y and x. So let's see. Let's go -2, -4. Let's do a couple more. Let's do -2, -1, 0, 1, and 2. That ought to be enough to get us somewhere. -1 goes to -3. 0 goes to -2. 1, -1, and 2, 0. So that's f of x. That means for f inverse of x, if I want to do my xy values, I just need to swap these. So -4, -2, -3, -1, -2, 0, -1, 1, 0, 2. I'm just going to double check that because I'm really easy to mess these up. That looks good. All right, let's plot these points. Get rid of these. All right, -4, 2. -2 is here. -3, -1. -2, 0. -1, 1. And 0, 2. So you can see that the inverse of this linear equation is this linear equation up here. All right, maybe you notice something about this, maybe you don't. Let's do another one. All right, I want you to try and sketch the graph of this function right now. So pause the video, pick off some x and y points, and sketch a graph of this function. The function's inverse, please. All right, let's do this one together. I'm going to pick some points off this graph, and then I'm going to switch them. So this is for my original function f of x. And I'm going to go, let's see. I need enough to make it look good. I think that might not be enough, but let's start there. So -2 looks like it's at about, let's see. That's 1, 2, 3, 4, 5. So these are about each 0.2. So -1.25. Ballparking here. -1 looks like it's at -1. 0 is at 0. 1 is at 1. And 2 looks like is at about positive 1.25. Might not be enough points, but let's see if it is. So my inverse function, because this as a function is a complicated shape, -1.25, -1, 0, 1, 1.25, -2, -1, 0, 1, 2. All right, let's graph these guys. So -2, is at negative 1.25. Yeah, I think I'm going to have to put more points on, unfortunately, because if you see, okay, negative, hang on. Okay, let's graph these points. Hang on. Okay, so negative 1.25 is going to be about here, and that's going to be at negative 2. That's here. And then negative 1 is at negative 1, so those cross. And then 0, 0. And then 1, 1, so those cross. And then 1.25 is at 2. So let's see if we can get that. That's where we might need a few more points. And I'm going to erase these because these are kind of confusing me. There we go. All right, I think this is okay. So it wouldn't be terrible to have a few more points. Let's go ahead and see what happens at a half. So if we put in negative 1/2 here, let's fill in the blanks. That would be here-ish. And negative 1/2 is at about negative 0.8. So that means that negative 0.8 on the inverse gets you to negative 1/2. Let's plot that point. Negative 0.8 gets you to about negative 1/2. So that's this guy right here. And then I think by symmetry, we can do the same thing over here. So if we put in 1/2, we know that's at about 0.8. So 0.8 gets us about 1/2. 1/2, negative 0.8 gets us to about 1/2. And that's here. Okay, I think that's enough points to kind of get the feel. So if I graph this, connect the dots, I get a nice curl like that. I should have used a different color than green. That's okay, I think you guys can see it. And it goes up like this. So is there something you notice about the graphs of the inverse function and the original function? Hopefully, or maybe not, I don't know, you might notice that they reflect about the line y equals x. So here's the line y equals x. And the graphs are going to be reflections across this line. And that's exactly because for f, we made xy equal to yx. So we switched the x and y values. So they're going to be a reflection across that. And you can see if we go back to our previous one, if you looked at y equal to x here too, the two graphs were a reflection across the line y equals x. All right, so that is graphing inverse functions. And the last topic we have now is checking inverse functions algebraically. Well, if functions are inverse, f and g, and you compose them, you should always get x out. Because g of x would take x to y, and f would take y back to x. So no matter what you put in, you should get what, if you put into a function and then back out the inverse, you should be right back where you started from. So we're going to try and do an example problem with this to check it. So this is something you should write down in your notes. This is how you know you can check algebraically if two functions are inverses. All right, so let's do one example of checking inverses algebraically. And this isn't actually the example I want to do. I'm going to change it. I'm just going to cross out this +5. It makes it pretty complicated. And I'd rather just have it without the +5. So let's scratch that out, pretend that's not there. We're just going to have it be this function right here. All right, first thing we're going to do is we're going to find the inverse of f of t, and then we're going to verify it using the rule in the red box. So why don't you pause the video and try and find the inverse on your own. Alrighty, you're back. Did you find the inverse? Hopefully you did. Y equals 3 over t minus 1. Switch t and y. We're going to solve this guy for y. So what I'm going to do is I'm going to do the old cross multiply and divide routine here. So I'm going to write t as t over 1, and then I'm going to cross multiply. And so that means I get t times y minus 1 equals 3 times 1, which is 3. That's a good trick whenever you have a variable in the denominator that you're trying to solve for, to get it out of the denominator. And now I'm going to divide both sides by t. That gives me y minus 1 equals 3 over t, and add 1 to each side. So y equals 3 over t plus 1. So my inverse function is f inverse of t equals 3 over t plus 1. So that was step 1, find the inverse function. Hopefully you guys got that. Now let's check it algebraically. So we're going to take f of f inverse of t. So that's f of 3 over t plus 1. That's my inverse function. So in my function f, wherever I see a t, I'm going to write 3 over t plus 1 minus 1. So this was my original function up here, right? 3 over t minus 1, but instead of writing t, I put in my inverse function. All right, let's see what we get. Well, this is 3 plus 1 minus 1. So that gives me 3 over t plus 1 minus 1 is just plus 0. So I can just put that in the middle then. 3 over 3 minus t. Now remember, dividing by a fraction is the same as multiplying by the reciprocal. So instead of dividing by 3 over t, I'm going to multiply by t over 3. Those are the same thing. So 3 times t over 3 is t. Sure enough, when I take if I take the function of my inverse function, I get my input back again. So I took my input to the output and then the output back to the input. So I'm back where I started from. So that's how you verify an inverse function. Now to be thorough, you should do f inverse of f of t and show that you get t that way too. And I'm going to leave that up to you guys to do in your notes right now.